Hello everyone, I'm Neelima. I'm working as Assistant Professor in Department of ACE. Today I'm discussing a topic in Digital Logic Design subject, that is Quine Mc Cluskey method, or we also call it as tabulation method. Now, at the end of this lecture, you will be understanding what is the need for Quine Mc Cluskey method or tabulation method, and you will be understanding how it differs from K-maps, and you can perform the Boolean minimization using a systematic tabulation procedure here by using this method. By considering an example, I will clearly explain that. And here we will be knowing what is a prime implicant and what are essential prime implicants, and we will be deriving the simplified SOP expression or POS expression by taking an example of this method. The main objective is not just to remember the algorithm, but to understand the logic behind each step. Now, first of all, before going to this method, why do we simplify the Boolean expressions? We have different approaches. We have theorems and postulates to simplify the given expressions. Not only that, we have studied the K-maps, that is Karnaugh maps, which are used to simplify the Boolean expressions. What is the need to simplify the expression? Suppose if we won't simplify the Boolean expression, more number of terms you will be having, more number of logic gates are required. More gates means more hardware components. More hardware components means it needs a high power consumption, large circuit area, and the cost of the design also increases, and it results in the more propagation delay. Why do we need the Quine Mc Cluskey method? Already you have studied K-maps. These are suitable only for 4 to 5 variable Boolean functions. For example, if we go for the 6 variable K-map, the number of cells required in that will be 32 cells. That means you have to draw 6 variables, it is 64 cells. That means you have to draw 4 variable K-maps, and once after representing the minterms, you have to group the cells. So it is a time consuming, and it may, if you do the wrong grouping, it may result in the errors. So Quine Mc Cluskey method, it provides a systematic tabulation procedure where you will be comparing the minterms here, which differ by 1 bit, and then you will be going to the next step. Then you will be finding the prime implicants. Then you will be finding the essential prime implicants by drawing an prime implicant chart. Finally, you will be writing the minimal SOP expression. K-maps, these are best for manual simplification, while the Quine Mc Cluskey method is the best for systematic and computer-based simplification of large Boolean functions. So if we have the variables more than 4 or 5, we always prefer Quine Mc Cluskey method, or we call it as tabulation method. Now, here we have a different steps in this tabulation method. Suppose, for the example, for the given minterms, the first step is you have to write the binary representation of the given minterms. For the given decimal numbers, write the minterms. The next is you have to arrange these minterms in a groups depending upon number of ones in the ascending order. First, you will be writing the binary representation, which consists of all zeros. The second group, it consists of the binary representation, which consists of single ones. And the next group, it consists of binary representation of the numbers, which consists of 2 ones. Like that, you will be arranging the decimal numbers of the binary representation in the corresponding groups. Then you will be compare and combine the terms. Here, when you are comparing or combining the terms, the adjacent group term should be compared. Only the first group should be compared with the second group minterms. And which groups you can compare here? The groups which differ by 1 bit has to be compared here. So once that is done, you will be finding you have to continue this process until no further grouping is possible. So finally, whatever the terms are left, we call it as a prime implicants. Then you have to go for the prime implicant chart. So for that, you have to create a table where the prime implicants will be represented in the rows, and the original minterms, it will be represented in the columns. And you will be checking for the corresponding prime implicants which minterms are covered. If any of the minterms are not covered, then you have to compulsory include the prime implicant which covers that minterm. So finally, you will be writing the simplified expression. That clearly by taking an example, I will explain that. Now, here this is a minterms given 0, 1, 6, 7, 8, 9, 13, 14, 15. You have to simplify this. Already I told you Quine Mc Cluskey method, or it can also be called as tabulation method. Step 1. What is the first step? For the given terms, you have to write the binary representation. I am taking the inputs as A, B, C, D. And the minterms, the decimal numbers, I am writing 0, 1, 6, 7, 8, 9, 13, 14, 15. For all these, you have to write down the binary representation. So, all zeros. For 1, 0, 0, 0, 1, 0, 1, 1, 0. For 7, it will be 0, 1, 1, 1, 0, 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. This is the first step. Now, coming to the step 2, you have to arrange these minterms as per number of ones. So, first, I will be writing the minterms with all 0 ones. That is, first I will write 0. After writing, just keep a tick mark there. This is one group. You don't have any other decimal numbers whose binary representation consists of all zeros. Then write down the numbers which consists of single ones. So 0, 0, 0, 1 for 1. Then single one is 8. So 8, that is 1, 0, 0, 0. Any other single ones? Only these two. So that is one group. I have closed that group. Next, for two minterms. For 6, you have 0, 1, 1, 0. That is 2 ones. Then for 9, 1, 0, 0, 1. That's all. This is considered as one group. Then for 7, 3 ones, 0, 1, 1. Then for 13, it is 1, 1, 0, 1. Then 14, it is 1, 1, 0. Then finally, you are writing the binary representation which consists of 4 ones, that is 15. This is step 2. Now coming to the step 3, now you have to compare the minterms present in the first group with the minterms present in the second group. So here when you are comparing, for example, here I have 0, 0, 0. This group 0, it should be compared with both the minterms present here, that is 1 and 8. Now, when I am comparing, you have to check that it should differ by only one variable. Now, if I see 0 and 1, it is differing by one variable here. Check here, A, B, C are same, but D is different. So, here, the term which I will be getting after combining 0 and 1 is A is same 0, B is 0, C is 0, but D is changing. Whichever bit is changing, that is represented as dash here. Now here, the same thing I am comparing here. So I am writing the inputs A, B, C, D, and the 0 and 1 can be combined because it differs by one bit. Whichever minterms you are combining, just keep a tick mark over there. So here it will be 0, 0, 0, dash. We have to check whether all the minterms are involved in the grouping or not. Next, 0 and 8 can be combined. 0, 8, dash 0, 0, 0. So keep a tick mark. Now this group comparison is done. Now the second group, that is 1, 8 minterm, should be compared with the 6, 9 minterm. So 1, 8 minterm is what? 1 and 6. Can I combine? I cannot combine because it differs by more than 2 bits. That is 3 bits are differing. I cannot combine. Now check for 1 and 9. 1 and 9 can be combined. So it will be dash 0, 0, 1. 1, 9. Then can I combine 8 and 6? 8 and 6 also it differs by more than 1 bit. Then 8 and 9. So 8 and 9 can be combined. So it is 1, 0, 0, dash. So this group comparison is over. But here we have not, you have to see here, there is no tick mark. That means this 6 is not involved in any grouping till now. Now, 6, 9 minterms in this group should be compared with 7, 13 and 14 minterms in the adjacent group. Now, 6 and 7 I can combine. So, 6, 7 as it differs by 1 bit. So, it will be 0, 1, 1 and dash. Then 6 and 13. 6 and 13, it differs by more than 1 bit. I cannot combine. Then 6 and 14, it differs by 1 bit. So I can combine. I will be getting dash 1, 1, 0. Next, 9 and 7, I cannot combine because it differs by more than 1 bit. 9 and 13. 9 and 13 I can combine because it differs by only 1 bit. 9 and 13. So 1 dash 0, 1. Then 9 and 14, it also differs by more bits, so I cannot combine. So here the comparison of this group 6, 9 and 7, 13, 14 is done. Now we will be going for the 7, 13, 14 with the comparison of 15. Now 7, 15 can be combined as it differs by 1 bit. So you will be getting dash 1, 1. Then 13, 15 can be combined. So you will be getting 1, 1 dash 1. Then 14, 15 can be combined. You will be getting 1, 1, 1 dash. This process should be continued until there is no further reduction in the steps. But here if you check again, you have 0, 1, 0, 8 is considered as one group. That group should be compared with the bits present in with 1, 9 and 8, 9. Now here when you are comparing, you have to check the position of dashes. The dashes position should be same and the remaining rule is same. The remaining bits should differ by only 1 bit. So here if you see A, B, C, D, next step 4 I am going. Now 0, 1 and 8, 9. In both the places, the dash is in the D place and it differs by only 1 bit. So I can combine 0, 1, 8, 9. So I'm keeping a tick mark 0, 1, 8, 9. Now what I can write here, A is differing, so it is dash. BC in both the cases is 0, 0 as it is and D is dash. Next, 0, 8 and 1, 9 if you see, both the dashes are in A place. And here D value, it differs by only 1 bit. So you can combine even these two. But 0819 or 0189 is one and the same. You will be getting dash 00 dash. So no need to write again. You know, in the Boolean algebra here, x plus x gives you only x. So no need to repeat that term again. You just can keep a tick mark over there. Now for this group, it is completed. Now 1989 should be compared with 67, 614 and 913 here. Now 19, the dash is in the A place. Similarly check for which term the dash is in the same first place. If I see 19 and 614, the dash is in the first place, but the bits differing is more than 1. I cannot combine. Then if we have 19 and 913, 19 and 913, I cannot because the dash is not. So I cannot combine. Then go for the 89 and 67. I cannot combine. So any of these second group terms I cannot combine with the third group. Now I will be comparing the third group with the fourth group. That is 6, 7. You have the dash in the D place. Similarly, if I take 14, 15, I have the dash in the D place and it differs by only 1 bit. So I can combine these two. So it is 6, 7, 14, 15. And the bit which we are getting will be dash 1, 1 dash. So 6, 7, 14, 15 can be combined. Similarly, 6, 14, 7, 15 also can be combined. It is nothing but you are getting dash 1, 1 dash. Both already I have written that combination. So there is no need to write that combination again. Next, you don't have anything written for this 913 cannot be compared because B place you don't have a dash in the adjacent group. So these are the final. Now again in step 4, check whether you can combine 0189 with 67, 14, 15. The dashes positions are same. You can combine, but you have to check the simple step is it should differ by 1 bit. But if you check that too, it is not differing by 1 bit. So we cannot combine. So these are the final prime implicants you will be getting. So wherever you don't have a tick mark, those are considered to be the prime implicants. So this is first, this is second, this is third, and this is fourth. Now for this you have to draw the prime implicant chart. Now I am drawing a prime implicant chart. As I discussed in the steps, the prime implicant chart, in the rows you will be writing the prime implicants. So the total you have 4 prime implicants. I am representing the 4 prime implicants 1, 2, 4. I am writing here PIs. PI refers prime implicant. So what is the expression for this first term? Now here if you see here, B value is 1, C value is 1. That means the term you are getting here is B into C. Which minterms are responsible for grouping this? 6, 7, 14, 15. By combining these minterms, you got the term BC. Now, the second term, it is B bar, C bar. By using which terms you got B bar, C bar? By using the minterms 0, 1, 8, 9. By grouping these minterms, you got the expression here B bar, C bar. Similarly, for the third one, the third prime implicant is, you got that by combining the minterms 13 and 15. What is the expression for that? For 15, it is AB into D. And this you got by combining 13 and 15. Next, the fourth prime implicant you got by grouping 9 and 13. So the expression for this is A into C bar into D. So in the prime implicant chart, in this rows, you will be writing the prime implicants. So these 4 prime implicants which we got here after simplifying the 4 steps, I have written here. Now in the columns, whatever in the problem they have given the prime minterms, those minterms you have to write. What are the minterms given here? Just write it directly. That is 0, 1, 6, 7, 8, 9, 13, 14, 15. Now, here, what are the minterms covered used in the first prime implicant? There you just keep a tick mark. In the first prime implicant BC, the minterms covered are 6, 7, 14, 15. So this term you got by grouping these 4 minterms. So just keep a tick mark over there. Next, B bar, C bar, you got by grouping the minterms 0, 1, 8, 9. Then A, B, C, D, you got this by grouping the minterms 13 and 14. And A, C bar, D, you got this by combining the minterms 9 and 13. Now you have to find the essential prime implicants. Essential prime implicants are those where the minterms are covered by a single prime implicant. For example, if you see here the minterm 0, it is covered only by the second prime implicant, that is B bar, C bar. So circle this. This is not covered by any other prime implicant. So we call this as essential prime implicant. That means compulsory in the final expression, this essential prime implicant should be included. Next, 1. It is an essential, circle that, because those minterms are covered by only one prime implicant. So 7 also single coverage, this 8 also single, but 9 is covered by 2 prime implicants, so it is not essential. Then 13 is also covered by 2, 14 is also covered by 2 prime implicants, 15 is essential. It is covered by only single prime implicant. Now you have to write the final expression. Now, when you are writing the final expression, you have to see that you have to include the prime implicants that are essential. So, all these essential prime minterms are covered by BC as well as B bar, C bar. That means compulsory 1 and 2 prime implicants should be included in this. So, what is the first prime implicant? That is BC should be included. Then B bar, C bar should be included. Now you have to check whether all the minterms are grouped here or not. For that, BC, what are the minterms responsible for that? 6, 7, 14, 15. Just keep a tick mark on that. Next, for B bar, C bar, what are the minterms? 0, 1, 8, 9. Okay. But here, if you see here, 13 is not involved. Whatever the terms I have written here, it does not cover the minterm 13. That means you have to write down the term or the prime implicant which covers 13. Now, for that, here you have 2 combinations here. One is ABD covers 13 as well as AC bar D also covers 13. So, in these 2, you can write any one. So, I am writing here ABD. Or, in place of this, you can even write AC bar D. Here the important point to note is, in the Boolean simplifications, the answer need not be the same. The number of literals should be the same. So if you see in both the cases, the number of variables are same. The means literal is nothing but individual variable. In this total, how many literals you are getting? 1, 2, 3, 4, 5, 6, 7. Total 7 literals. So in this also you are getting 7 literals. So in the Boolean expression, you have to check whether the literals or not is same or not. In the same way, you can simplify the given POS function also. But in the POS function, instead of writing the SOP expression here, we will be writing the POS expression here. Similarly, if the same thing, if you can simplify this by using the K-map also, you will be getting the same answer. For this 4 variable K-map is required to simplify this function, and you, depending upon the grouping of the cells, you will be getting either ABD or AC bar D as an answer here as the third term. Okay. You can solve these examples here for the practice examples. Thank you.